application. HPLC or high pressure liquid chromatography is a method that we use to identify specific compounds in a mixture. The first step involves preparing the mobile phase. The mobile phase carries the compounds through the column. For this, we have just mixed acetonitrile and ultra-pure water in certain amounts. Although these compounds can vary depending on your experiment. HPLC columns contain a stationary phase attached to a support material that is typically porous silica particles. These silica particles provide a large energy surface area. They are crucial in HPLC for separating sample components. The main type of columns are normal phase, ion exchange, reverse phase, and size exclusion, with the reverse phase being the most common. C18 is a widely used phase within the reverse phase, particularly for analyzing small molecules under 5,000 Daltons. Alright, the mobile phase stands up here, and here the degrazer, which prevents microbubbles in the capillary system. Here the pump. With the help of this pump, in HPLC system provides a mobile phase flow, and the specific materials in this complex solution can reach the column. These specific materials, called analytes, reach the column and interact with column filling material in various ways and reach the detector at different times. Samples are put here and injection is performed through the downside. Here is the column oven. If the column is heated, pressure decreases. The heat we use depends on the stationary phase of the column as well as the samples. A column oven allows separation. And finally, a diode array detector is utilized for recording the UV absorption. Here is the whole system of HPLC. First, we start with labeling the vials, because it's necessary to write the names or numbers of the tubes. Then, fill down the 14 lines that I am shown here and enter the method name. Injection volume was used as 10 macroliter. Injection volume shows how much sample will be analyzed in each vial. In our previous analysis, it was 20 by the way, but it is not that much essential because it will be the same limonene content, for example, everywhere of an orange peel. I mean, it is uniform in a complex solution. So we copy paste the same labeling on data file, okay. Now it's extremely important to check your vials whether it corresponds to the same number or not. Otherwise, we might not be able to verify our samples well. Okay, here is the page that we can control what's going on in our experiment. Finally, we wrote our experiment's general name. It's ready to go to analysis. After waiting the HPLC analysis, there's a complex chart must be obtained. Now we pay attention to area which suggests when the limonene was the most abundant. Our samples were including really high density of limonene, so we diluted them in the beginning. We found that the analytic standard of limonene 6.4, that literally says if we see something on 6.4 minute, it must be limonene. However, it wouldn't be fully clear in spite of these data were converted to Excel. Nevertheless, there are three things we can apparently see that 5.7, 5.9 or 6.9 might be limonene. In the next step, we should try to undergo another sample to HPLC in order to calculate it properly. Alright, let's click here. By the time, if you could wait a little bit, you will be able to see that the pink line over here, it would be more clear results because it is a calculation to measure integral from the limits that we have established previously. My limonene project was approved by the Scientific and Technological Research Institution of Turkey, in abbreviation TÜBİTAK. I carried out these experiments thanks to my instructor, Professor Mehmet Fatih Cengiz, with his students.